Good morning to all. In this today's class, we are going to see about the particle nature of light, Einstein's explanation. So in this Einstein explanation, according to him, the energy of light is not spread. But it is concentrated in small pockets, or that is energy quanta. So that quantum is given by the energy level. So that is E is equal to h nu here. So and also he proposed that quantum of light, and also that quantum of light has linear momentum, that magnitude is also equal to P is equal to h nu by c. So it can be come from the two energy levels, equate the two energy levels, that is E is equal to mc square and also E is equal to h nu, and you have to rearrange that. So you will get mc is equal to, that is mc is equal to, the remaining part can be taken as a here, that is h nu divided by c. So mc means mv, that is c is also considered as a velocity of light. So that is mc is equal to p. So p is equal to h nu by c. So that can be related in this equation. So by this conclusion, the light quantum can behave as a particle, and this is called photon. Therefore the photon is called a particle of light. So now we will see about the characteristics of photon here. So the first one, the photon of light, that is it can be given by the energy level E is equal to h nu. So you know that C is equal to nu lambda. So that means nu is equal to C by lambda. So therefore E is equal to hc by lambda. And also here nu is a frequency and lambda is a wavelength of the electromagnetic radiation. And the second one, the energy of the photon is determined by the frequency only, frequency of the radiation, and not by its intensity. So the intensity has no relation with the energy. So it is only on the frequency of the radiation. And the third one is the photons travels with the velocity, and the light, that is velocity of light, its momentum is given by, I already told you, you have to equate the two energy level, that is E is equal to mc square and also E is equal to h nu, and you will get mc is equal to h nu by c. So mc is equal to p, so that's why p is equal to h nu by c. And also the fourth one, the photons are neutral and it does not affected by electric and magnetic field. And also fifth one, the photon interact with matter, the total energy, the total linear momentum and all the total angular momentum are conserved. So that are all conserved, since the photons are observed by new photons may be produced in such interaction, the number of photons may not be conserved. So here all the energy level and also the momentum level is conserved, and it can be produced in interactions. So the number of that is photons may be conserved. So these are all the characteristics of photons. Next one is Einstein's explanation of photoelectric equation. So now he framed the equation about the photoelectric effect. So in this equation, when the h nu of energy of photons is incident on a metal surface, it is completely absorbed by a single electron. So suppose if you are considered by a single electron and the electron can be ejected. So because of it can be overcomes the potential barrier energy and it can be ejected out. So what happens here, the potential barrier of the metal surface, that is the electron can be ejected, means it can be done by the work function that can be denoted as phi naught. Work function is denoted as phi naught, and also the remaining energy is considered as a kinetic energy of the ejected electron. So according to him, the law of conservation of energy, so h nu is equal to, that is when the photon of energy incident on the metal surface, that is h nu is equal to what happens, work function plus kinetic energy. So work function means phi naught plus kinetic energy half mv square. Here m is the mass of the electron, so v is also the velocity of the electron. So this is the diagram representation of the emission of photoelectrons. So here the A picture shows the kinetic energy of the electron, single electrons, and it also, the B picture shows the work function. So here E is equal to H nu, here also E is equal to H nu naught because of work function. The first, it can be come out at the surface of the metal, so that is E naught. So this is the, it again the kinetic energy. So the maximum kinetic energy is considered as H nu minus H nu naught. H nu naught means it has a minimum frequency, it can be come out, the electrons can be come out at the, that is overcome the potential barrier. So kinetic energy, maximum kinetic energy is equal to H nu minus H nu naught. So you know that H nu naught is equal to phi naught. So here the nu naught is the threshold frequency, that is the minimum frequency the electrons can be ejected, come out. So here H nu naught is equal to phi naught. Substitute this value on the above equation. So this is the equation, H nu is equal to H nu naught plus half mv square. So this is the Einstein's photoelectric equation. Here H nu is the photon of energy, and also H nu naught is the photon of energy that can be come out with the minimum frequency of the, that is threshold frequency, it can be come out the electrons out, and also it gains the kinetic energy half mv square. So half mv square is considered as a k, that is maximum kinetic energy here. So Vmax is also the maximum velocity of the electrons ejected. So that's why you want to find out the kinetic energy, means kinetic energy is equal to H nu minus phi naught. You know that phi naught is equal to H nu naught. So see this graphical representation. So this is a graph between kinetic energy versus the frequency. Here the minimum frequency V, that is nu naught, the H nu naught of energy is considered. So and after that it has attained the maximum kinetic energy, the electrons can be come out, so it can be gains the kinetic energy, maximum kinetic energy. So this diagram represents the H nu naught portion is a minimum frequency the electrons can be ejected, and H nu is considered as the maximum kinetic energy produced in the electron. So this is also the graph between the kinetic energy for different metals. So in this metal, cesium, potassium, sodium and calcium are there. The work function is also given here. So I already told you, and also we calculate at that introduction class how to calculate the work function for all the metals. So you just go through it. So the cesium, the work function is minus 2.14, and also for calcium minus 3.20 electrovolt. So like that you have to take the slope values for that. So that is considered as a H here. H is the Planck's constant. So these are all the values and agreed with the practical prediction also. This is the this experiment, the milligauss is also calculate the value of the Planck's constant like that. So now we will see the next topic, explanation for the photoelectric effect. So in this explanation for photoelectric effect, first one, we will increase the intensity of the light. So it also increases the number of electrons emitted. So, and the second one is, from the kinetic energy, H nu is equal to phi naught. So it is directly proportional to the frequency of the light, and it is independent of the intensity of light. And the third one, the minimum energy, so that is equal to the, for incident photons, it can be able to liberate the electrons from the metal surface. So below that, emission of electrons is not possible. So it has a minimum threshold frequency only, it can be ejected out. So there is, in below the frequency, that is threshold frequency, there is no photoelectric emission here. And the last one, according to the quantum concept, the transfer of photon energy of the electrons, and also the electron can be ejected, in between that there is no time lag of that. So because within a fraction of seconds and also within a fraction of milliseconds it can be able to do that. So this is the instantaneous time it can be taken that, and when the photon of energy is emitted, that is passed through on a metal surface, what happens the next, at the moment then there is no time lag, the instance of electrons can be ejected, come out. So these are all the photoelectric effects. So the next topic is photoelectric cells and their applications. So in this photocells, The photocell is also one of the device which can be able to convert the light energy into electrical energy. So, and it has been works at a function of, that is on the principle of photoelectric effect only. So here also the simple, the when the light is incident on the material, that is photosensitive material, the electric properties will get affected, and also it can be classified into three types. So what is that? Photoemissive cell, and also photovoltaic cell and photoconductive cells. There are three types of photo cells can be produced here. So first one, photoemissive cell, it is working depends upon the electron emission, so due to the eradication of light. And second one is voltaic cell, it is also used, which generates voltage proportion to intensity of light. And third one, the conductive cell, so it is also the resistance of the semiconductor changes in accordance with the radiant energy incident on it. So these are all the different level of, we are changing the different levels at the metal position, and also the intensity of the light, like that. So in this lesson, the photoemissive cell is given and it can be explained. So first one, we see the construction about the photoemissive cell. What is meant by photoemissive cell? It is working depends upon the electron emission from a metal, that is cathode. Depend upon the cathode metal. Working, and it depends upon the electron emission from the cathode metal. This is the experimental arrangement of this photoemissive cell. So let us consider here evacuated glass or quartz bulb. So let us consider that inside of this quartz bulb or evacuated glass bulb, so the cathode and anode can be considered. So C is the cathode and A is the anode. Though C, the cathode is semi-cylindrical in shape. So and also it is coated with the photosensitive material. So here the anode is in a thin rod or wire. It can be kept along the axis of the semi-cylindrical cathode. When the potential difference is applied between the cathode and the anode, so and also the current is passed through, it can be denoted by the galvanometer G. So working when the cathode is eradicated with the suitable radiation, that is you have to pass one of the ultraviolet radiation to the cathode side. So what happens? Electrons are ejected, come out, that can be emitted. So these electrons are attracted by the anode, and hence the current is produced, that can be shown by the galvanometer. So for this given cathode, the magnitude of the current depends upon, so that current can be produced in the galvanometer, no? So that can be depends upon the intensity of the incident radiation, and also the potential difference between the anode and the cathode. So this is the depending of the current, that is the magnitude value of the current here. So application of this photo cell is, it can be used for many application, but especially for the switches and sensors here. So you know that the automatic lights turn on at the roadside, no? So when it gets dark, the photo cells can be emits the light, and the street lights, it can be switch on and the switch off according to the weather, it can be night or day, using the photo cells. So these photo cells used for reproduction of sound in motion pictures. So and also used as a timers to measure the speeds of athletics, and also during a race. And also these photo cells are used as a photography, so it is used to measure the intensity of the given light and also calculate the exact time of exposure. So these are all the usage of this photo cells.